We are on question number 43. This is a triangle in which the white space that remains in any given stage in the next stage is then halved every side. This computer hates me. The sides of the white space are halved. Those are the midpoints, and then another triangle is drawn in and shaded. And so in the next step, you would half the white spaces in all three of these places, draw that in and shade it. What you'll notice is that the number of triangles gets greater and greater and greater, even though they're smaller, but the shading gets denser and denser. However, the area, and in this situation they're calling area A sub n, the shaded area, it's going to be limited, which means it's going to be finite because the entire fractal is bound within the area of the original triangle. So A sub n is finite. However, if you notice what's happening with the number, the perimeter is what it's calling it, but the number of black lines in here of all of those shaded regions, as they become more and more and more, there's more and more perimeter. But the question is it finite? And in this situation, it may not be intuitive, but the answer is no. It's actually infinite. Technically, lines have no thickness, even though obviously the black ink that was used to print this does have thickness. So even when you can't see it splitting, it's still splitting and outlining new little triangles. And so actually the P sub n, or perimeter, is infinite. Okay, so the question is, which of those is true about the perimeter? The only one that approaches a finite limit is A sub n, and that answer is C.